random variable can only take a finite or countable number of distinct values. Examples: let X be the number of students randomly selected to be interviewed by a researcher. Another is let Y be the number of women randomly selected in political rally. Continuous random variable can assume as infinite number of values in an interval between two specific values. Example: let X be the weight of randomly selected students in kilograms. Another, let Y be the height of daisy plants in the backyard. Discrete probability distribution. A listing of all possible values of a discrete random variable along with their corresponding possibilities. It can be represented in tabular, graphical, or formular form. Example number 1. The given spinner is divided into 4 sections. Now, let's find the probability of the following. But first, let me show you the formula needed in order to get the probability. P of E is equals to N of E over S of E. So now, let's know the chances of getting 1 in the spinner. 1 over the total number of number space, which is 4. 2 is 1 over 4. 3, 1 over 4. And last, 1 over 4. To get to C, first combine like terms. And then 29C is equals to 0.29. Divide both sides by 29. Cancel and you will get C 0.01. Next, 29C is equals to 29 times 0.01. And you will get 0.29.
Mass function of a discrete random variable. A probability distribution describes the probability of each specific value in a random variable. The probability of a discrete random variable is called probability mass function. It is denoted by f of x and satisfies the following two basic properties. The support S of a random variable is the set of values that the random variable can take. It contains countably infinite number of possible values. This means that the elements of S can be put into one-to-one correspondence with the set of natural numbers.
Let's apply the sigma notation. Summation of 6 to 8 to be substituted to kx. Let's substitute the variable to x. Then add all the like terms to get the value of k. Then we will get 21k equals 1. Then divide both sides by 21k. And we will get k equals to 21. And our final answer would be f of x is equal to 1 over 21x if x is equal to 6, 7, and 8, then and 0 otherwise. Let's prove the equation is an example of PMF, considering the two properties. The property letter A, check. The property letter B, substitute 1, 2, and 3 to f of x is equal to 1 over 6x equals to 1, check.
The expected value of a discrete random variable x is denoted by E of x is equal to the weighted average of the elements x in the support S, where each element is weighted by its respective probability. Given the following, Use this formula, then substitute the value of x here. So you will put 1, 1, 2 and 2, 3 and then 3. So calculate this and you will get an answer of 7/3.
The mean variance is standard deviation of a discrete random variable. It is the mean of DRB, is also called as expected value of x, and it is the average outcome obtained in the trials. So here is the formula, where x is the discrete random variables, x is the outcome or value of the random variables, and p of x is the probability of the outcome of x. So here is the example number 1. As shown in the table, let's find or solve the expected value of x. First is let's add all the xp of x values. 0 plus 0.50 plus 0.50 is equals to 1. And that's all. That's the final answer.
Variance and standard deviation of a discrete random variable. For the formula of variance of a discrete random variable, we have summation of quantity x minus mu squared times p of x, where x is the outcome, mu is the population mean, and p of x is the probability of the outcome. And for getting the standard deviation is just getting the square root of the variance, where standard deviation is equals to the square root of summation of quantity x minus mu squared times p of x.
In the given table, how are we going to get the value of summation of x p of x? Just add all the values that can be seen in the third row, then to get the values in fourth row, subtract the value that you have get in summation of xp of x to the values in first row. Then proceed and do the same thing as what you did in group data on last session. And add all the values in sixth row and you will get $1.8475, which is your variance. And to get the standard deviation, just square root the value of the variance and you will get 1.3592. Given the data on the side, let's apply the alternative method. First, let's multiply the first column to the second column, and here are the values. Then, get the sum. The answer will be 2.95. Next, let's square the values on the first column. The answer would be 1, 4, 9, 16, 25, and 36. Next, let's multiply this to get the final column. 0.15, 1, 2.7, 2.4, 2.5, and 1.8. After getting these values, let's sum this up. So 0.15 plus 1 plus 2.7 plus 2.4 plus 2.5 plus 1.8. The answer would be 10.55. After getting these values, let's subtract this to this. Then 10.55 minus 2.95 squared based on the formula. Then we get the value of 1.8475, which serves as our variance. And answer was the same in the first video. To get the standard deviation, just square root this value.